In this recording, we'll watch several videos that illustrate implications of the impulse formula. Okay, for example, here we have a mango. A mango, not sure how many of you are familiar with it. It has a hard cover, soft flesh, but then also a hard nut inside. And to cut it, usually it's not a very easy process. But then if I'm going to cut it, if I'm going to try to cut it in two or in small chunks, if I'm going to use any kind of instrument for cutting it, I have to do two things. Now, my mango is going to stop my cutting device. It's going to change the momentum of my cutting device. So by exerting a force on it. The reaction to that would be the force that the cutting device is going to exert on the mango. So the larger is the momentum of the cutting device, the easier it's going to be to cut the mango. So I can accomplish that by starting with a cutting device that has a large mass and a large velocity. So it's going to come up hitting it with a large momentum, and then the mango is going to stop it, so that cutting device is going to have a final zero momentum. So by having a large change in momentum, that means I'm going to need a big impulse, big change in momentum, and then if I exert that change in momentum over a short time, then the force exerted on the mango and on the cutting device is going to be a large force. Let's see what they do here. See that? Okay. Let's play it again. They didn't aim right, they didn't hit the middle, but there. So it acted, it's heavy, and it was fast. So it acted over a short time. Again, so its momentum is from the momentum it had just before it touched the mango to zero when it stopped there, when it hit the pavement there. Okay, let's see another example. Now here we have this, I believe he's a high school kid, and this high school young lady is holding a wooden board for him that he's going to try to break with his bare hand. Now this guy is not wearing any martial arts attire. I have no idea if he did practice any martial art or not, but you don't need to practice martial art to break a board like that. You just need to believe in physics. Okay, and let's see what he does. See that? Okay. Notice when he does it. Notice that his hand moves forward. It's actually his hand, once he breaks it, is going to be closer to the young lady. And you see, to do it, he had to move his hand fast. Okay? So the hand moving fast, that's a large momentum. The board is not going to be able to give. So it's going to exert, it's going to try to change the momentum of the hand. The time in contact is short, since the board does not give. That means the force responsible for the impulse is going to be large. And the force is going to be large enough to break the board. Now, I'm not saying that this happens all the time, and I'm not saying that women cannot do it, but this particular woman seems she had the wrong idea. Okay, you see here also she didn't hit it at the middle, I think, or she might have, I don't know. But notice what's happening to her when her hand bounces. You see, the other guy didn't worry about being hurt, but she worries about being hurt. And this is because of what we talked about before. In this case, because her hand is going to bounce back, that means the piece of wood exerted twice the force on her because there is twice the change in momentum than if her hand had stopped. The fact that her hand didn't stop and bounced back, it means the change in momentum is twice as big. Remember the happy and the unhappy ball. So her hand acted like the happy ball, bouncing back, twice the change in momentum, so twice the force. That's why she feels hurt. Okay, now look at this guy. 1, 2, 3, 4, 5 boards. Notice the gap between them. And that's the idea, is you break the first one, and the first one is going to break the second, and so on. See that? That's quite impressive. Now, another implication of this, the video is not such a good quality. You can do this at home. I like the fact I chose this video because it has someone holding a potato vertically. And what he has a drinking straw, a plastic drinking straw, that he's going to try to ram through the potato. Now, let's see what happens. Okay, I didn't precise that, but that's a raw potato, and the straw was able to go through the raw potato because he gave it a large enough momentum. So it was a large momentum that the potato was not able to stop. So, and it was moving quite fast. The straw was moving quite fast. So the force exerted by the potato in trying to stop the straw had acted over a short time. There was a short time of contact. So since it's a short time, the force is quite large. Potato didn't give large force, then the force allowed the straw to go in. Okay, this particular example is also quite interesting. We have a broomstick that this gentleman that we'll see in a second had placed in between two wine glasses. And then he's going to come really fast through the middle and try to break it. Okay, so it's showing us the broomstick. He positions it between on the glasses, and then look at that. So he hits it with another stick quite fast. So the fact that he gave that stick a large enough momentum, the broomstick could not apply a force large enough to stop it. So the force acted over a very short time. It was a large enough force to break the broomstick, but not large enough to stop the other stick. You notice here, the glasses didn't break. If the force was slow, then you'd be able to break the glasses. Okay, this is another illustration of that. We have here a bed of nails, and this gentleman is going to sit on it. They are going to put the concrete block on top of him, and they are going to get a sledgehammer and break that concrete block. Okay. Now, never allow someone who can inherit you do this kind of experiment with you. What happened here? Let's replay it. Pay attention to the momentum of the sledgehammer. It is moving fast and it has a large mass. So it's going to have a large momentum when it is about to hit the cinder block. So it's a large momentum. The cinder block is not going to give, so it's going to try to stop it over a short amount of time. So the force that's going to act on the cinder block is going to be a large force, a force large enough to break the cinder block. Okay, look at it again. Now, if the guy instead tried to push with the cinder block, push on the cinder block with a sledgehammer, that would not be a comfortable situation for this gentleman. Okay, let's see other implications. Actually, this is out of place. Let's see this one first. Okay, this guy, you notice he's walking over broken glass. Not sure how well you see it, but this is broken glass, just random glass pieces, like out of broken bottles, and he's walking over it. If you really notice, he's not jumping on the glass. He's walking slowly with bare feet. Okay, here what he's doing. He's laying on broken glass. I walked on broken glass, but I have never done this laying. I have someone standing on him, and that's still no problem. The person who was taking pictures is actually standing on him right now. Okay, I didn't fully explain this. Let's hope this video will help us get an idea. See, we have a balloon here. We are pushing down on it, and it does not pop. Then we move a bunch of nails and put it on top of one nail, and then it pops immediately. Now, what's the difference? When you have lots of nails, and when you are pushing down on it, all of the nails together are going to contribute to the normal force acting on the balloon. Now, each one of them is going to contribute a portion of what's needed for the normal force. So each one of them then is going to apply a little normal force. And that little normal force is not going to be large enough to break the plastic. Now, however, when we had only one nail, the nail has to apply the overall normal force. And that's a large normal force. So it's large enough to break the plastic. In the case of the gentleman on the bed of nails, that's the same idea. If he tries to sit on one nail, it would have hurt. But having a bed of nails, each of the nail is going to exert a portion of that normal force that's needed to hold him in place, that's needed to support the guy in place. Now, breaking the cinder block is a different story. The force exerted on the cinder block is going to be enough to break the cinder block, but not enough to move the cinder block, and that's why, since the cinder block is not going to move, the force was exerted over a short time, it's not going to try to push the guy down on the nails. So it does not affect what he experiences. Now, when the guy walks on broken glass, it's the same idea as this. Each piece of glass is contributing with a little bit of the normal force needed to support the guy. Now, if it was just one nail piece, one piece of glass, it would have been a different story, and it would cut through his skin. It would be large enough, the normal force would be large enough then to cut through his skin. Now, when he laid down, actually it is even easier and safer than walking, because he's using many more pieces of glass that way to support the same weight that he has. And even when someone stands on him, because he's using more pieces of glass, it's not going to hurt him.